we will start the next chapter, that is the design of bolted beam connections. In this chapter, we are having sir, in this you are having both in this chapter you are having both bolted beam connections and welded beam connections. So generally in industrial sector, it consists of beams and columns. The load from the beams will be transferred to the columns. So here the load on the beams may be a direct machinery load or a secondary beam load. So the structure consists of primary beams and secondary beams. Both the loads from the secondary beam and primary beam will be finally transferred to the columns. So while transferring from secondary beams to main beams or primary beams, the secondary beams should be connected to main beams, and again the main beams or primary beams will be connected to columns. So finally load will be transferred to the columns. So you have to make the connections by means of bolted connections that we will consider today here. So here the bolted connection, if it consists of single bolt, it will act like a hinge. A single bolt, it will act like a hinge. So if it is a hinged structure, is the resistance of it will give any resistance to bending moment? It will not give. So it will resist the shear. A simple single bolted beam connection at the ends. It will resist the shear force at the ends, but it will not resist the bending moment. So bending moment will not be resisted in the case of a single bolted connection at the ends. Suppose we want to resist the bending moment also, we have to make the ends to be acts like a fixed beam. So fixed beam, in the case of fixed beam, so along with the shear force, moment also resisted at the ends. So reactions will be in the form of shear force and the resisting bending moment at the ends. So in some cases, partially resist the bending moment. So here some movement, only some movement will be along with the shear force, some movement will be resisted by the connection at the ends, beam connection at the ends. So here three categories are there. So one is the simple beam connection, that is going to resist the shear force. Generally shear force will be maximum at the supports. So it will resist the shear force, but if it is a simple single bolted connection, it will not resist the end moment. So then such type of connection is known as the simple connection or flexible connection. This one here it is given, first one, simple connection or flexible connection. In this one, so shear force will be resisted and it will not be able to resist the bending moment. So this is the one case. Second one, moment resistance or rigid connection. Nothing but it is acting like a fixed beam. In the case of fixed beam, the end reactions will be vertical force and moment. Here also same. It will resist the connection will resist the shear force along with the moment. So moment is also resisted in the case of a moment resistance or rigid connection. And third one is a semi-rigid connection. So it will resist the shear force and partially resist the bending moment that is developed at the end. So these are the three types. So we will consider one by one. The simple beam connection, or first one, simple connection or flexible connection. That is going to resist the shear force and it will not be able to resist the bending. So here first case, simple connection or flexible connection, these three categories are there again. So framed connection, first one. Second one is unstiffened seated connection. Third one is the stiffened seated connection. So we'll see what is the difference between these three types of simple beam connections. So framed connection, if you observe here, the diagrams we will consider one by one. So this is the main beam and this one is the secondary beam. So secondary beam to main beam, the load will be transferred through this connection, bolted connection. This one. So this is the side elevation of the secondary beam and this is the section of the secondary beam. This one is the primary beam. So load from the secondary beam will be transferred to the primary beam. So here we will consider framed connections. So when the end shear is to be transferred is less, it is possible to connect the beam to the main beam, that is secondary beam to the main beam, or to the column using a cleat angle shown in the figure 81A and B. So 81A, so this is one type, this is the other type, 81A and B. So shear force is less, it is in the connection shear force is less. So this one, this side elevation, this one, side elevation of the secondary beam, and this is the cross section of the secondary beam. So secondary beam is connected to the main beam by means of a cleat angle or web angle. So this is the one angle on one side of the secondary beam, another angle on the other side of the secondary beam. So this is another. Here the secondary beam is connected to the main beam here. This A and figure A. This second one, figure B. So here the beam is directly connected to the column. So web of the beam, this one, is connected to the flange of the column. This is the side elevation, this one, first diagram. And the second diagram is the sectional elevation of the beam, this one. So two angles, cleat angles are connected to the beam to the column. So these are the bolted connections, this circle and the plus type connections. So this is a simple one. So when this will be considered when end shear force will be transferred from the beam to the column is less in magnitude. And bending moment is 0. It will not be able to resist any bending moment. And shear strength depends on the web of the beam. This framework connection. Second one is the unstiffened seated connection. Unstiffened seated connection. We'll see the another diagram. Second one. So when the shear force is larger, the depth of the cleat angle required for the frame connection may be more than that can be provided in the available space. In such cases, seat angles are connected to the column over which the beam rests. So consider the second one. So here, if you observe this, these are the seat angles. The bottom and seat angle and the top seat angle. So in this one, this is the beam and this is the column. So the beam rests on the seat angle. This one. The stanchion means nothing but a column. So this cleat angle or seat angle will be connected to both the beam and column. So flange of the beam is connected to the flange of the column. So this is the side elevation, first diagram, and this is the sectional elevation of the beam. This one. So both the beam, this one high section, is resting on the cleat angle, and the cleat angle is connected to the flange of the column here, at the bottom and at the top. So here the magnitude of shear force to be resisted is greater when compared to the previous one. This is another type of connection, beam to the column. The second one, unstiffened seated connection. When the shear force is larger, the depth of the cleat angle required for the frame connection may be more than that can be provided in the available space. So in this case, cleat angle requirement is more in the connection, then we will go for seat angle connection, that is this one. So this will resist the more shear force when compared to the previous one. And third one, stiffened seated connection. Suppose if the shear force is to be resisted is much more, then it requires more support to the beam. The seat angle may fail. To strengthen it, a stiffen angle may be provided. A stiffener angle may be provided as shown in the figure 8.4. Such a connection is known as stiffened seated connection. If you observe 8.4, this one. So here seat angle is here given. This one, side elevation. This is the beam and this is the column. Seat angles are there. The shear force is large and this may not be able to resist that much magnitude of shear force. Then it will be stiffened. That is, if you observe here, another two angles are provided here. The sectional elevation is చూపలేదు ఇక్కడ దీనిలో wrong diagram ఇక్కడ ఉండేది. So this is another two angles are supported to the seat angle. So here seat angle ఉండాలి కదా, అక్కడ చూపలేదు ఇక్కడ లైన్ ఉండాలి ఇక్కడ. So this is stiffened seat angle. So there are three types. One, when shear force is less, then the beam is directly connected. The web of the beam is directly connected to the web of the another beam, main beam, or it may be connected to the flange of the column. This is one. When shear force is less, cleat angles will be sufficient that are bolted to the beam and the column, beam to beam. This is the secondary beam and this is the main beam in the A diagram. In the B diagram, a connection between the beam and column. So this will be used when the magnitude of shear force is less and the depth of this number of bolts are required is less. So this space is available is sufficient for the bolted sections. Suppose if this space is insufficient, the requirement of the cleat angle length or number of bolts are more, then we will go for seat angle connection. That is seat angle connection. This one. The beam rests on the seat angle and then it is bolted. Seat angle is bolted to the flange of the beam and flange of the columns. So the transfer of shear force is much more, and this cleat angles may not be able to resist the occurring shear force. Then we will go for stiffened seated connection. That is vertical support to the seat angle is provided by means of another two angles. These two angles, or the required number of bolts are provided. So these are the three types of bolted connections in the case of a simple beam to beam or beam to column connection. The second one is the moment resistance connection. So moment resistance connection will resist the shear force as well as the bending moment also. So in this one, I forgot to tell one more thing here. If the top of the connection should be at the same level, so this is one beam and this is the another beam, secondary beams. So the secondary beams flanges may be cut like this, so that the top surface will be in line to the main beam. So this is in the case of simple beam connections. In the case of moment resistance connections, so there are two types. Moment resistant connections may be further classified as clip angle or split beam connection. Second one is the bracket connection. So first one is the clip angle connection. This type of connection can be used at the end if the moment to be transferred to the end is small. So just in the case of earlier, shear force is small, then we will go for one type of connection. If it is greater, more, then we will go for the other two types. So here also, if the moment to be resisted is small, then we will consider the clip angle connection. This is the clip angle connection. All these are the figure A. Clip angle connection. This is the side elevation of the beam. This is the column. This is the sectional elevation of the beam and the column. And this is the top plane. This is the column. And this is the beam. So clip angles are provided. So seat angle on the top and clip angle also. So cleat angle you can consider also. Cleat angle is also provided so that it will resist the shear force and bending. So this is the first type. This is the second type. Clip angle and split beam connection. So here angles are provided. Here the T section is provided. The flange of the beam is connected to the flange of the column. In the second diagram, this one B, split the beam connection. So T sections are provided instead of the angle sections. T sections are provided. So these are the bolted connections. The bolted connection is consisting of T sections here and the angle, cleat angle section here. So this is clip angular split beam connection. Second category in this one is the bracket connection. Is shown in the figure 8.6. So if you observe this, the shear force is more and moment is more, then we will consider a gusset plate. A triangular shaped plate is provided. So only sectional side elevation is there. This is the beam and this is the column. So here consisting of a triangular plate is provided here, that is known as the gusset plate. So angles are provided on both sides of the gusset plate here in the vertical direction and the horizontal direction, and cleat angle is provided beam to beam, web of the beam to flange of the column. Here again cleat angles are provided in vertical direction, horizontal direction, connecting the beam and also the connecting to the column with the help of this gusset plate. So if it is provided, it will resist the more moment and shear force. So that is known as the bracket connection. So now consider the design of this frame connections using the bolts. First category type, we will consider bolt. The bolts connecting the web of the beam to the cleat angles in double shear, so the number of bolts required to transfer the end shear should be determined. They may be accommodated in a single or double row depending upon the availability of the depth. So first, if you consider first type, here if you consider here this diagram, simple beam to column or beam to beam connection. Here the shear force from the secondary beam is transferring to the main beam. So if you consider these bolts, these are in double shear. Here one shear plane is there, another shear plane is there here. So they are in double shear. They may be accommodated in a single or double rows. That is the design requirement. The bolts connecting the cleat angles to the main beam or columns are under single shear. So if you consider this, the bolts connecting to the cleat angle to the beam. So these are in single shear, only one plane is there. Whereas if you consider here, these bolts, two planes are there. So double shear, the bolts will get double shear. So whereas this bolts will get single shear. This one. That is the elevation. This bolts will have a single shear. So this will have double shear passing through this web of the secondary. We will consider also one problem. The size of the cleat angles depend on the number of rows of bolts provided, minimum edge distance and spacing decided the size. So the size of the cleat angle also you have to design. That depends on the pitch of the bolts and number of bolts, and minimum edge distance will be provided, and spacing, that is pitch, that you are going to decide. That will influence the length of the cleat angle. Thickness of the cleat angle also should be selected, that the strength of the cleat angle per pitch width is more than the strength of the bolt. So here another consideration is thickness of the cleat angle connecting the beam to column or beam to beam depends on the strength of the angle. So the strength of the angle should be more than the strength of the bolt. The strength of the cleat angle per pitch width is, or pitch length is more than the strength of the bolt. So these considerations you have to consider while designing the simple connection. So we'll consider one problem. Here an ISLB 300 carrying a 50 kN per meter has an effective span of 8 meters. This is to be connected to the web of the girder ISLB 450. Design the framed connection using 20 mm block bolts. So here ISLB means Indian Standard Light Beam. 300 is depth of the beam. 300 mm is the depth of the beam. It is having a UDL 50 kN per meter and having a span of 8 meters. This is to be connected to the web of a girder. That is the main beam, ISMB, Indian Standard Medium Beam. 450 means 450 mm depth. Design the framed connection using 20 mm block bolts. So you know what is meant by block bolts. A bolt consists of shank and root. The shank is turned exactly in circular shape, then it is not known as block bolt. Only a rough surface will have. The block bolts will have rough surface on the shank, and roots will have root. So the shank is not exactly square in the case of, exactly circular shape in the case of block bolts. It will have a rough surface, so it requires more clearance when compared to the circular, smooth circular surface of the shank. So now we'll consider the first step, connection of the cleat angle with the web of the secondary beam. So you have to know the strength of the bolts in double shear. So web of the beam, secondary beam, the bolts will be in double shear. So you know this formula. This is the area of the cross section of the 20 mm diameter bolt, and Fu by ultimate strength in root divided by root 3 partial safety factor for material of the bolt. This is the one shear plane is in shank portion and another shear plane is in root portion. So this is 1 plus 0.78. So this will give the strength in double shear, this one 103.31 kN. So that is strength of the bolt in shear, double shear. Now in the bearing also we have to consider bearing, the strength of the bolts in a bearing. So edge distance is, it is not given, you have to consider, that is 40 mm is considered, which is 60 mm. So you have to find the KB value for bearing strength of the bolts. So least of these 4 values, this you know already in the design of bolted joints. The least value is considered. TW is the thickness of the web of the beam. This you will get from the steel tables, web of the secondary beam. This ISLB 300 having a web thickness of 6.7 mm. So in this formula we will substitute the values, KB value, and then we will get the strength of the bolt in bearing. So this is 66.587 kilo. So bolt value, the lesser of the two, shear and bearing, you have to consider. Shear it is 103 double shear, and bearing is 66 kilo. So this value will be considered for the design purpose. So now the end reaction. So what is the total load here? UDL of 50 kN per meter and span of 8 meters. So total load will be 50 into 8, and shear force that is to be transferred at the ends is 50 into 8 divided by 2. So 2 supports are there, one each at the end of the beam. So 50 into 8, this one, total load divided by 2 will give the shear force, end reaction. So you consider the factored shear force multiplying with 1.5, this is the design shear force. So the number of bolts required will be the force to be transmitted 300 kN divided by the bolt value. So this much bolts are required in double shear. So 4.5 here. So we go for the higher value. 5 we cannot provide, and provide 6 bolts in 2 rows. So we have to provide 6 bolts in 2 rows. That is connecting secondary beam to the main beam. So 3 in each row. Now connection of the angle with the web of the girder. So main beam. Connection of the cleat angle to the web of the girder. So thickness of the main girder is web thickness is 9.4. This you will get from the steel tables ISMB 450. Now strength of the bolt in single shear, because the cleat angle and the main beam will be having the bolts which are having in single shear. So only the area of the cross section in the root zone of the bolt is considered, that is 0.78 times the diameter. These are the FE by root 3, and this is the 1 by gamma MB. This gamma MB is 1.25. So in the single shear you are getting 45.27 2 kN. And the bearing, strength in bearing also you have already considered 45.2 here. Bearing. So bearing, if you use this formula, you will get bearing value. Bearing value you have get this one 66.587. Same bearing value here also you will get the bolt. So bearing is higher. So shear is considered here, single shear 45.272. So the shear force to be transmitted is 300 kN divided by the bolt value, it will give 6.6. So 6.6 you have to go for higher value 7. Instead of 7 odd number, you go for even 8. So 8 means provide 4 bolts in each angle at 50 mm spacing. So that is provide in 2 rows. This one 4 bolts in each angle. So one side 4 and the other side 4. Design of the cleat angle. So this bolts design is over. Now we consider what is the length of the that required and also the thickness of the cleat angle. So to keep the bearing strength of the cleat angle greater than the strength in a single shear, thickness of the cleat angle is given by. So this is the strength, bearing strength of the cleat angle is greater than the single shear, that is considered here. So at least means you have to equate single shear to the bearing strength of the cleat angle plate. So this is the bearing strength and this is the single shear strength. The thickness is unknown here. So diameter is known, KB value already known, F is the ultimate stress, this one gamma MB is the partial safety factor. So this is for the board, this is for the cleat angle plate. So if you substitute this value, you will get T, required thickness of the cleat angle. So 4.56 mm is required. So 5 mm is not available, you go for 6 mm. So Indian standard angle of size 150 by 75 by 6 mm. Angle with 150 mm leg on the secondary beam, so that 2 rows of bolts may be provided. So then depth of the angle required on the secondary beam. So this is the secondary beam, this one. So we are getting 6 number of bolts for the secondary one. So this is the 40 is the edge distance here, 40, and then 60 plus 60 pitch length. This is again end distance 40. So total depth of the cleat angle is 200 mm. 200 mm. Requirement 40 plus 60 plus 60. 200 mm. And again depth of the angle required and the main girder. So here 40. So here 1, 2, 3, 4 bolts, 4 on one side and 4 on the other side. So pitch of 50. So out of these two, you have to consider the higher one. So because you have to provide the same length of the cleat angle. So higher one you consider 230. 230 mm length of the cleat angle is considered. So provide 230 mm long cleat angle as shown here. This is the diagram here. This cleat angle you have to design. First you have to design the shearing strength of the bolts, the bearing strength of the bolts, the shearing strength in double shear. This the cleat angle connecting the bolts that are used for connecting the cleat angle to this. This is the secondary beam, ISLV 300. This is the UDL. It is having UDL. So it requires 6 bolts. They are arranged like this. And for this, it requires 8 bolts, which is connecting the main beam, cleat angle to the main beam. 8 bolts means 4 bolts on one side and the other 4 bolts on the other side. So that is the back side of this secondary beam. So this is the arrangement of the bolted connection. So this is simple one, simple beam connection. This will be designed. So if it is designed unstiffened seated connection, so another type is design of unstiffened seated connection. This we will consider in the next class. So is there any doubts in this one?